Good morning, everyone. First of all, I would like to thank Shai for his presentation, because now I wish I had added memes to mine. But this is my first ever public speech, so let me introduce myself. Thank you. Well, my name is Gaetano, and I'm an IS engineer at Telepass Digital, the technological unit of Telepass. And my talk for today is about the latest advancements in collection views. So I know this topic is not really that new. In fact, all of the APIs we're going to look at have been introduced in iOS 13 and 14, but it's still pretty interesting to look at. And also, I know it's not SwiftUI, but it's still pretty interesting. So we're going to look at some examples. For example, the App Store, Apple's Music app, and also a custom view inspired by our apps at Telepass. And by the way, the source code for all of the examples will be available at the end of the session, so don't worry, you'll be able to review everything at your own pace. So we'll start with the first example, and first example is a simple list. So Apple introduced new APIs to create lists in collection views back into iOS 14. So if you've never looked at these APIs, you may be thinking, well, does that mean the table views are dead? Well, I wish they were, but unfortunately, not yet. But there are still good reasons to use lists in collection views. And in fact, they inherit all of the appearances in table views, but also bring some new ones, such as the sidebar appearance. But then they also give us the ability to effortlessly expand and collapse sections. And we're going to look at how we can do that. So we can already dive into code, and we will create the layout first. We'll create an instance of UICollectionLayout list configuration with a sidebar appearance. And then we will also create an instance of UICollectionView Compositional Layout by using the list method. And we will use the configuration we just created. So this is all we need to know about compositional layout for now, as we will discuss it later on with the next examples. So that's all we need to do in terms of layout to create a list in collection view. But now we actually need to provide some data to our collection. And to do that, we're going to use the Diffable data source APIs introduced in iOS 13. So Diffable data source provides behavior to manage updates to both data and our UI. And they work with some kind of state. So we also have Diffable data source snapshots. And of course, they are the representation of the state in our data source. And in code, it translates into these two types, UICollectionView Diffable data source and NS Diffable data source snapshot. And they're both generic over two types, a section identifier type and an item identifier type. And the data source, we use these types to identify the models in the collection. So we've introduced these two concepts of the data source and the snapshot. But let's stop for a second to think why they're called diffable. So we'll get the current snapshot of our data source. And we can see it contains items 0, 1, and 3. And all of these items are identified by numbers. So we'll get a copy of this snapshot and then modify it and insert an item identified by the number 2 between item 1 and 3. So we apply this snapshot on the data source, and it will understand what is actually changed by comparing it to the previous snapshot. So the data source would think, well, now I need to add a cell between item 1 and item 3. So it will add a cell for us. So the thing here is that, as we said before, the Diffable data source provides behavior to manage updates to our UI. So it will take care of all of the UI updates for us. And it works with all of the insert, delete, move, and reload operations. So now we can create the model for our data source. And we will create two simple enums types. And one represents our sections, and the other represents our items. Now, in this case, since we're displaying a static list of items, we will only use the string as associated values in our items to display a title in our cells. Then we will create a method called applyInitialSnapshot, which applies the initial state of our collection view. So we'll create an instance of NS Diffable data source snapshot, then append all of the sections we want in our collection view, and then the items that belong to specific sections. and then we will apply the snapshot. And of course, we also need to store an instance of our data source somewhere, and we'll store it in our collection in a view controller. But now we actually need to display cells. And from the old days of collection views, if you remember, we also had to implement the set-for-item method, and inside of that, we had to dequeue our cells. And if you were using custom views for your cells, you also had to downcast them. And then you could actually configure them. But before doing that, you actually needed to register the cells with some unique identifier. And luckily, Apple improved this process by introducing new APIs for cell registration and configurations back in iOS 14. So UIKit provides us with this type called cell registration, which is generic over the UICollectionView list cell in this case, and our item model. So we also need to implement disclosure where we can actually configure the cell. So in this case, if we're using a UICollectionView list cell, we will get the default content configuration, then modify it with our text, and then pass the configuration back to the cell. And thanks to this configuration, the cell will actually be able to understand that it will need to display a title label. Then we also need to initialize our data source, and inside the initializer, we also need to implement the cell provider. And the cell provider is a closure that allows us to dequeue our cells. We're also given the item as an argument, so we can just switch over it and then return the appropriate cell. So in this case, for the header cell, we'll just return nil, and then for the item cell, we will dequeue a cell by using the dequeue configured reusable cell. And it will allow us to configure our cells with the cell registration APIs. So if we will then run, this is the result we get. But now we also want to add headers to our sections. So we will modify the apply initial snapshot method to add header items to the sections. Then we will create a new cell registration instance to configure our header cell. And again, we're using a UICollectionView list cell, but now we're also adding some accessories to our cell. And we will add the outline disclosure accessory, which will allow us to display a chevron next to the title label, but also enable the expanding and collapsing behavior on our sections. But now if we tap on our header cells, nothing will happen. And the reason is that we're using regular snapshots. And the regular snapshots do not support the expanding and collapsing behavior of lists. In fact, Apple introduced a new type of snapshot called Diffable Data Source Section Snapshot. And it's similar to the regular snapshot, but it only manages one section of our data source. So we can refactor our code to support this new snapshot. We will create an instance of NSDiffable data source section snapshot, which is generic only on our type. But then to enable the expanding and collapsing behavior in our list, we also need to create a relationship between the items. So we will need to append a parent item, which in this case is our header, and then children items to our header, which in this case is our items. Then we will create another snapshot for the other section, and then apply both of our snapshots. So finally, if we tap on the header cell, we get expanding sections. Now for the next example, we're going to look at the App Store. And the App Store has always been popular for its complex layout. And in fact, it's the perfect example to introduce the basics of compositional layout. So compositional layout is a new API introduced in iOS 13, which allows us to create layouts for collection views. And just by looking at the App Store example, we can already distinguish the basic elements of a compositional layout. In fact, we had this view that represents an app, and in compositional layout, we call this an item. And it's the most basic component of a layout. But then we also had 3 of these items laid out vertically, and in compositional layout, we call this a group, which is a container for 1 or more items. Then we also had multiple groups laid out horizontally, together with some additional views, in this case, a header. And they're all containing what we call a section. So now that we've introduced the basic elements of a compositional layout, we can finally dive into code, and we'll create our items first. But before we can do that, we actually need to specify the layout size of our items. And layout size obviously determine the size of the item in our layout. And its dimensions are expressed through layout dimensions, which is also a new type in compositional layout. So here for the width, we specify a fractional width of 1, and fractional dimensions allow us to specify a fraction. So in this case, what we're saying is this item will cover the full width of its container. Then for the height, we specify an absolute height of 64 points, which means this item will always be 64 points tall. And then we can create our NS collection layout item instance by passing the layout size. Then same for the groups, we also need to specify a layout size. So here we're specifying a layout size with a fractional width of 0.92. And that means this group would be slightly smaller than its container. And the reason we do that is because we want to be able to see multiple of these groups at once on screen. Then for the height, we specify an estimated dimension, where its dimension is equal to the item size, the item's height, multiplied by the number of items we want to display. So an estimated dimension actually allows us to tell the layout that we think this group will be this much tall, but we'll actually let them figure out the actual size. So the collection view will determine the size of this group after the content is being rendered, which is perfect for dynamically sized items and groups. Then we can finally create our group instance by using the vertical initializer method, since we want a vertical layout. And of course, compositional layout provides us with many different methods for layouts in groups. For example, we also have the horizontal method and then the custom method, which allows us to specify a completely custom layout for our group. So we can pass in the layout size of our group, then the item, and how many items we want to display in the group. Then we can create the instance of NS collection layout section, which will contain our group, and then an instance of UICollectionView compositional layout, which will, in this case, will only take in the section. So this is our result for now. And of course, we still need to work on a couple of things. And let's take care of the spacing between the items first. So compositional layouts allow us to specify content insets for our items, groups, and sections. And content insets allow us to modify the size of the content, in this case of our item. So we'll specify only a leading and trailing inset. But then we can also specify the edge spacing, which allows us to specify the spacing from one item to the other on each of its edges. So for now, we'll only specify the top and bottom edge spacing. But if we look back at the App Store, these groups should be laid out horizontally, and we should also be able to scroll through them. And by default, collection views actually lay out their content on their main layout axis, which in this case is the vertical axis. Thankfully, compositional layout introduces this feature called orthogonal scrolling, which allows us to lay out content on the orthogonal axis, which for this example will be the horizontal axis. And as the name implies, with orthogonal scrolling, we can specify different scrolling behavior. And for this example, we're going to use the group paging centered behavior, which will page and center the groups inside our sections. So as you can see, every time we swipe, the groups center in the section. Now with the next example, we try to recreate the music app layout. And this is actually the perfect layout, the perfect example to understand the true strength of compositional layouts. And in fact, just as the name implies, compositional layouts allow us to compose different layouts in one single collection view. So our goal here is to display a list in one section and then a grid of items in the other section. So we'll create this method that creates the layout section for our list. And because of the composability of compositional layout, we're also given a list initializer method on the NS collection layout section type, which will also take in a layout list configuration instance. And this time we're going to use a plain appearance. Then we will create the layout for our recent section, which will only basically create a grid of items. So we will create a layout group with a horizontal layout, and it will always display 2 items. So when we initialize our UICollectionView compositional layout, we can use this initializer where we can specify the section provider. And the section provider is basically a closure that gives us the index of the section, so we can switch over our section and then return the appropriate layout for that specific section. But then we can also specify a layout configuration, which allows us to modify properties on the layout configuration. So in this case, we're only modifying the spacing between the sections. But now we also want to display a title on the recent section. And with boundary supplementary items, we can add headers and footers to sections in our layouts. So just like regular layout items, we need to create a layout size which specifies the size of the item, and then we can create the NS collection layout boundary supplementary item instance, which will take in our layout size, then an element kind identifier, which identifies the element, and then an alignment. And with this alignment, we're specifying on which edge of our section we should attach our item. So in this case, we're using the top alignment. Then we also need to add this item to the boundary supplementary items of our section. But of course, it is not enough to display a header. We also need to implement this supplementary view provider on our data source. And just like the cell provider, with supplementary view provider, we can dequeue our supplementary views. And with we can also use the registration APIs for supplementary views. So in this case, we're going to use the dequeue configured reusable supplementary method. And we can use a supplementary view registration instance for this view as well. And we get a title in our section. Now, for the last example, we're going to look at our apps at Telepass. So we have this view that we call offer view, and it's used to present the users with our offers. But what we're looking at here, we're mainly looking at here are two sections. A section of horizontal laid out cards, and also many different expandable and collapsible sections. So we will take care of the lists first. So we'll create our model. We'll create a simple section enum and then an item enum. And as you can see, all of the cases have associated values, have identifiers as associated values, which is a better approach to work with Diffable data source. Then we're going to look up the categories in our storage, and for each category, we will create a section snapshot. So we will get a copy of the section snapshot, and then again, we need to create a relationship between the items. So we will append the category item first, and then append all of the service children items to the category item. And then we can finally apply the snapshot. Then we will create a layout, and as I said before, this is a completely custom layout. We won't use the list APIs, and we will use custom views for our cells. So in this case, we specify a layout size where the height is an estimated height. And this is going to be important later on. Then we will create a layout group with a vertical layout. And this time, we're not specifying explicitly how many items we want to display. And the reason is that when we specify the items, this method will tell the layout to ignore the estimated sizes. In fact, the layout will use all of the available space in the groups to equally size all of the items. And that's not what we want. So now we also want to add a background to our sections. And to do that, we can use decoration items, which are used to add backgrounds to sections in Compositional Layout. So we'll create a NS collection layout decoration item instance by using the background initializer method. And we will also need to specify an element kind identifier. We'll modify the content instance of our item and then add it to the decoration items array of our section. But of course, we also need to register this view and assign it to an identifier. And we can finally display a background on our sections. So as I said before, we're using a completely custom layout with custom view types. So we won't get the expandable and collapsible behavior out of the box. We will need to implement it ourselves. But luckily, section snapshot exposes the methods we need. So we will create this method, and we will get the copy of the snapshot identified by a specific category. We will ask it if that category item is expanded, and if it is, we will ask again the snapshot to collapse it, otherwise to expand it. And just applying the snapshot will actually enable this, the expanding and collapsing behavior in our lists. But since we're displaying an arrow in our cells, we also want this state to be reflected in our UI. So we will call the setExpansion method on our storage, and then we will ask again the snapshot if the category is expanded. Then we will get a copy of the snapshot, of the data source snapshot, and we will ask it to reconfigure the category item. And with the reconfigure items method, we are actually asking the collection view to execute the registration and configuration closure again without actually reloading the cell, which is much more efficient. Then, of course, we also implemented the selectItem method from the collection view delegate, so we can call the toggle category expansion method. So as you can see, every time we tap on the category cell, we get expanding lists. So now we also want to display the offer section, which, if you remember, is the horizontal section of cards. So we will add the offer section to our enum, and then the offer case to our item. Then for the layout, again, we will create a layout group with a horizontal layout, and we're going to use a orthogonal scrolling behavior of group paging centered. But I've talked to our designer, and he actually wants the card in the center to be highlighted, which means all of the other cells should be smaller. And he also wants the scale of the cells to be animated whenever the user swipes. So the solution will be to use UICollectionView Layout attributes, which is perfect for transforming and modifying the cells before they get displayed. But in this case, it's not really the solution we're looking for. And the reason is, in order to scale our cells, we also need to track the content offset of our horizontal scroll view. And the problem is, when modifying UICollectionView Layout attributes, the collection view only gives us the main scroll view of the layout, which in this case scrolls vertically. But thankfully, Apple thought of that and introduced the visible items invalidation handler. And that's a closure where we give in the visible items and the content offset of the scroll view. So we can get the scale factor that it's computed depending on the offset, and then apply the transform to our cells. So finally, when we're scrolling, we get the scaling behavior. And this is great, but there's actually a catch. And in fact, if you build this on your Macs, the Xcode will print a log in your console stating that the section invalidation handler cannot currently mutate visible items for layouts containing estimated items. And in fact, if you remember, for our service section layout, we actually used estimated dimensions because we want our content to be dynamically sized. So it looks like it's actually working, but every time we try to expand our sections, we get this weird animation. And I've tried to debug it for so many hours with a colleague, and we couldn't figure out a solution. So the visible items invalidation handler is the perfect solution depending on your case. But anyway, I've provided an alternative solution which uses UICollectionView Layout attributes, although I wouldn't recommend using it since it looks through the subviews for this scroll view. It's not really great. So hopefully I've give you some cool